All right, so hello and welcome to 2168. Let's see, we've got 35 people in, and I asked for people, hey, email me if you aren't making it for some reason. So let's see, have I gotten frantic emails from people that they can't join? Because Zoom is having issues. So, um, foundation. So yeah, somebody's in issues with. Okay, yeah, I've got some people who are saying that they've had issues with Zoom. Ha, man, I've got just this flood of emails. It's kind of amazing. Um, okay, so we've got 36 people. Anyway, I'm recording. All right, so the first thing I need to do is attendance, because this semester that's what's required of me. So to do attendance, let me go ahead and share my screen with you to show you how it works. Okay, so share screen, screen one. So here we go. Right here is our Canvas website. For me to take attendance, I click on attendance. And you're going to be doing that as well in a second. And I hit start check-in. So, and then I hit start check-in. And then you can check it, and basically you can check. So you'll want to just check in and basically say, I am present for this class. And attendance is not graded. This is for COVID tracing. I don't know really why they're doing it for virtual classes. I assume mainly because if somebody is absent due to COVID, they might be somewhere else, but you'll be doing this for anything that has a synchronous or for a synchronous meeting time. So you just want to go to attendance while I'm blathering on and doing stuff. I'll end it at some point. So let's see, I've got a chat. Let me move that. Quickly is the attendance service. That is the company that is running these attendance services, or that provides the program that takes attendance. So you'll go in. If you don't sign in, you'll get a if you have an issue with attendance, just let me know. If you aren't able to sign in for some reason, then again, let me know. The attendance is not required in this class, or rather, I don't grade you on it. You should show up to class, but I'm not going to penalize you if you don't. So next, that being said, let's go to our home page. Okay, home page. All the information for this class should be listed here. This may be slightly more organized than you might be used to for your other classes. Not just this front page, but what I've got in general, because this is kind of the course I have got down. I've got it really working well, and I've got a system for this course. So here's me, my email, the Zoom link for that I'll use for office hours and lectures, my phone number if you need to text me or call me, and my office hours. Click here to reserve time for office hours. The way this works, click here. You'll be asked to log into Google, and you'll see that there's blocks for office hours. You just click on the block corresponding to the time you want to meet me, write your name, and boom, I'll meet you then. Okay, and you can do that for demoing your labs, or for just general help or whatever. And it will create a link in my calendar as well as your calendar. Okay, by default they're 15 minutes. I don't necessarily see that needing to be longer. Let's see. You might be noticing that I'm getting Discord notifications. So I'll get to that in a second. Next, we have our textbook, which I've switched from required to recommended, because a lot of what you'll be able to get is on my videos. It's a pretty good textbook, though, for data structures in general. Okay, next, under other important links, I have a Discord channel for this class, actually for all my classes. So just simply go, it's called Rosen's Classes. You've got a channel for a general channel and a channel for each of the classes. This is a great way for me to answer really quick messages, or for other students to answer really quick questions. So there's also stuff like, hey, I need some tech support stuff, or I don't know what laptop to buy, as well as, you know, study rooms set up if you want to meet with people. You know, in general, this is a more casual way for me to communicate with students, because I can reply to your question with a GIF. My YouTube channel, where I put all the lecture videos, will be right over here. Like all the stuff you'll be watching for the flipped classroom, which I'll get into, is there. And also all the code that I've written is on this link. If you're in section 1, this is your TA. If you're in section 2, this is your TA. I'm going to go ahead and quit Discord right now, so I'm not getting these notifications. This is my dog. She will help me grade. I have a dog and 3 cats. So anyway, the way this course works is that this is a flipped course. The idea here behind this is that computer science is hard, right? And you generally get these issues where you have this thing you want to solve, and there's this bug preventing you from solving it, and you're banging your head against it for 3 hours, and then you come to me and I go, oh, I see the problem, and I fix it in 5 seconds, something that you've been working on for 3 hours. Not only is that highly demoralizing, but it's an ineffective use of time, because you just wasted 3 hours. So the idea behind a flipped classroom is that we take the stuff that is mentally the least taxing, which is listening or watching to a lecture, and moving it to where you would normally do the homework. And then we pull the homework into the lecture, where you would normally be doing where you're doing the most taxing things when I'm most accessible. Now, I've been doing this for a number of semesters. This works really well, I find. So what you'll see here is, for our modules, is that I've broken it down, and a module doesn't necessarily correspond to a week, although for a lot of weeks it does. You'll click on Module 1 Overview. It will tell you, hey, here's all the stuff you want to have, a link to the videos, the assignments, a quiz, but those are also listed in their own pages. So for instance, here are all the videos that we have for this course, for this week. You'll notice that there's 7 of them. They're actually quite short. These are my first week of videos. I did them a while ago. They're meh. You don't necessarily need to watch them though, because this week is review. And of course, how are you supposed to watch videos before you join the class? How would you know? That seems unfair. So we're reviewing object-oriented programming this week. If you need a refresher, because it's been an entire summer full of madness and heat and virus, then this is there for you. But for next week, you'll want to watch the array list lectures, which are here in. So you want to watch these videos over here, array list videos, to do these. Now, these first videos, the first video in each of these modules is a general overview, and they're generally very high quality because we produced them for our graduate program. That being said, I also produced fairly high quality videos over here.
This is the
for our program, where I've got a green screen and I'm just simply walking through different programming things on these videos. Generally, the way it is that I introduce a data structure and I discuss how to use it, and then I discuss how to build it from scratch. But again, for our first lecture, we're going to be just talking about reviewing stuff. So let me just, syllabus is over here. It's worthwhile to just take a look at it, but in general, put in the required statement, we meet via Zoom. All the labs are from on Tuesday from 9 to 1050. Your section just depends on who you have, on what you signed up for. Right. Try to make it to your lectures. If you can't, just let me know. If you have issues because this is stressful, let me know. The sooner you let me know you're having issues, the easier the quicker I can make accommodations for you. Similarly, if you have disabilities accommodations that need to happen, just contact DRS, and I'll be happy to talk to you in person about any additional accommodation you need. I am really chill about this. You know, I am really understanding. I really want to make sure that you are, that any BS that happens in your life will not, that basically minimizes the impact it has on your learning as much as possible. So, you know, you've got a weird situation that because you got a quarantine, let me know, and let me know what accommodations do you need. Is the final as understanding as I am? I wish. Yeah, no, it's actually not too bad. Actually, though, it will be very understanding this semester because of the way the lateness policy has been altered. So, in general, quizzes are at 10%, labs and assignments are at 25%. I might mess with these numbers a bit to make the labs and quizzes worth a bit more, and the exams and final worth a bit less. Okay, so I just got to consult with the other professors that in this to, you know, make sure I'm not doing anything too wild. So your homeworks are your labs and assignments. They're the same things. The way this works is that you submit them online to Canvas once you're done with them. This creates a paper trail, but the big part is demoing. A big part in computer science interviews is doing a whiteboard coding and explaining your code. And explaining your code is kind of hard if you haven't had to do that before. So we give you the chance to do that. It also acts as a basic plagiarism detector, because if you can't understand your code, if you don't understand what you wrote, there's a good chance you copy pasted it or you just grabbed it from a friend. So that being said, you'll see that we do allow you to work together in groups. In fact, I highly encourage that you work together in groups. We are very lenient with late work, by the way. Very, very lenient. Quizzes and exams, they are timed basically. So the difference between a quiz and exam is a quiz. In my class, a quiz is a short assessment that basically that you choose when to do it. You have some due date and you choose when to do it. And, you know, they've got to be completed in, say, like 15 minutes or something like that, or 20 minutes, depending on it. And they can be started at any time prior to the due date. No worries there. Exams are proctored assessments that will be done in your lab. Okay, so you'll have basically a full 2 hours to do them. The final exam will happen whenever they say it's going to happen, according to the Temple Registrar. Please note, by the way, that in the past, it has a reputation for being difficult. And I see those. I see those comments, and I'll get to them, the chat. So part of the reason is due to the timing of it. It's generally the second to last day of finals. So everybody's kind of just already had it with their finals and final projects. So please study for this one. It's just, there's a lot of material to cover. Also, please note that if you have 2 finals on the same day, or you have more than 2 finals, university policy is that you cannot take more than 2. So if you have a professor telling you that you've got to take 3 finals in one day, one of your professors needs to move and accommodate for you. Okay, so just keep that in mind. So here's the late policy that will keep you sane. Late assignments, you can submit them late with a penalty of up to 5 points to a day, with a maximum penalty of 50 points. That means that if your assignment is that basically I'll always accept your late work, and the worst it will be is half credit. So you can basically always turn in something for half credit. Okay. Also, your lateness on the late policy is determined by when you turn it in, not by when you demo it. You have up to a month to demo it, because sometimes meeting for office hours is weird like that. Anyway, that's with assignments. You do have to demo all your assignments. Okay. With regards to the quizzes and project for another class, I completely forgot to remove that. So late quizzes and exams are penalized at a completely different rate. They are penalized at a rate of 0.1% per minute over the due date or the time limit. Okay, so let's say you're taking an exam. You got 2 hours to take the exam, but you need 10 more minutes to finish up your problem. That's no problem. It's just simply a 1% off that grade because you got 10 more minutes than everybody else did. If you need another hour because things are insane and you're just having a really rough time, you'll be penalized 6%. And this goes all the way up to about 1,000 minutes, at which point it's a 0. So you've got basically you've got essentially as much time as you need to complete an exam or a quiz. That makes sense? That being said, they are intended to be done within like an hour, hour and a half time range. So I'm not intending them to be a whole day thing but if you need the time, it's there. Make sense? It does make our sense to turn in. So yes, you generally want to turn in your work on the due date and demo later. And generally, if you have to make a change, if it's a small change, if you got to make a change, I'll tell you to make the change basically very quick. If it's a quick change, you can make it very quickly. If it's a very complicated change, I might tell you that you need to come back and show me that you changed it. But generally, that's why you want to demo as quick as possible. That being said, you get the chance to demo in lecture, in lab, and during the office hours. So those are all appropriate times to demo. Any questions on that? Yep, everything is online for this class. Okay, and in fact, we're going to start our first lab today. Yes, although if you demo it, we would have detected the issue beforehand because we give you your grade when you demo it, or we don't give you a grade and tell you to fix it. Okay. So academic honesty. Generally, I try to be very reasonable with the way things work. In fact, I am a firm believer that the best way to learn something is to teach it to somebody else. Also, programming rarely happens like on an individual level, so I highly encourage you to work with other people. Okay. That being said, so there's basically 2 types of labs: group projects and non-group stuff. For group stuff, you can turn in the same code. That makes sense, right? 2 people, if it's a group project, it makes sense for you guys to turn in the same code. If it's not, then your code should probably be different, but you can work to others. And you can show your code to others when you're asking for help, but you can't show them code to give them an answer. That is kind of the restriction I am imposing here, and because otherwise I don't want you to necessarily cheat. I don't want people to necessarily cheat unintentionally off of other people. Here is a list of basically things that I think are reasonable and things that I do not think are reasonable. If, however, you violate this and feel guilty, let me know within 72 hours, and I will, very strongly, make sure that you're not penalized for that. The big thing here is that I want to be very clear as to what I think is appropriate and what's not appropriate. But I want you to work together. That is a big thing. I want you to work together. I want you to be able to show your code to somebody else or paste your code on the Discord channel and say, hey, I'm having some issues here. Where's my bug? I want you to be able to do that kind of thing. Right? Those kind of things are perfectly acceptable to me. In fact, I'm on the Discord channel, so you can totally paste your code in Discord and say, hey, can anybody help me? And I might chime in and say, yeah, you got to fix this. This is part of the whole, I don't want you to bang your head against for 3 hours against a problem that will take me 5 seconds to solve. And the reason it's going to take me 5 seconds to solve as opposed to your 3 hours is A, I've made that mistake a million times, and B, I've seen your fellow students make it a million times. So it's not so much that I'm way more skilled, it's just I've made more mistakes than you ever have. So I will update the syllabus if I need to, but in general, this is the way it is. Any questions? I know it's really unusual to be doing this via Zoom. I know it can be a bit difficult, but I will try to make this as painless as possible for everybody. Okay. I will also be uploading all the recordings of this to YouTube, just FYI. So if you have issues with that, let me know. That may mean that your name is on the YouTube channel. So like on the video over here. But so just giving you a heads up about that. But I found that YouTube is basically the easiest way to communicate, to host things, because I know that YouTube works for everything. Okay, so with that, let's talk about what you're doing this week. So you're going to be doing this in lab and in the lecture. Now, I will be joining the labs, but they will be running simultaneously, so I will be jumping from one lab to another. So I will be helping out the TAs with the labs, especially for the first weeks. So this assignment is one I've been doing for the past couple semesters, and I found it's been really enjoyable. It's called Fox and Rabbit. A PDF summary of it is here, but I'm going to go over the basic rules of it here, and the source code is here. Now, if you haven't imported a project before into an IDE, first off, I don't care what you use. If you want to use VS Code, that's great. If you want to use Eclipse, awesome. IntelliJ, fine. NetBeans, fine. In general, though, this is the way that it works. We click on this. Let's go ahead and save it, and save it to our desktop, my desktop. I'm going to go ahead and extract the files. Extract. Okay. And there's our Java files. Okay. Give me 1 second to get my IntelliJ up here. So here's where it is, but I'm going to go ahead and make a new project and show you how to import them. So like in general, this is the way it works. You create a new project, however that looks in your IDE. Next, next. And I'll just call it Hunt, even though it's Rabbit Hunt. Or I'll call it maybe Fox and Rabbit, assuming I can spell Fox and Rabbit. Right, so you create your new project, open in this window, it's going to look empty. And I'm sorry that it's really tiny here. That's just the way it works on. But here I'm highlighting my SRC folder, okay? Here's how you import basically in Eclipse, in IntelliJ, and in NetBeans. You click on your SRC folder. That's where the source code files go. Select all of them, either by selecting them with the mouse or hitting Control-A. Hit Control-C to copy, or right-click on them and hit Copy. Move back to IntelliJ. Either highlight SRC and either press Control-V or paste. It will come up with something like either copy or refactor. Just hit the OK button and boom, there's our code. Make sure it's in the SRC folder, otherwise, because that's where your IDE is looking for code. If you have issues with this, and don't worry, you're not alone if you have issues with this. Everybody messes this up at least once. Then let me know, and I'll be happy to work with you in a breakout room. I will be splitting you all out into breakout rooms in a bit, by the way, to help to do this. And so here's our source code. So you've got two main files in here, one called Grader and one called Rabbit Hunt. Grader obviously is going to be your grade, but Rabbit Hunt, let's go ahead and take a look at this. Now this is looking like a big scary thing, but I guarantee you it's not as big and scary as it looks. That is a constant theme in my classes, by the way. Things are less challenging than they appear at the first glance. So let's go ahead and run Rabbit Hunt, and I'll summarize this for you. Okay, so I'm just running it. It's compiling it, running on main. It may look like a blank window for this. I'm going to go ahead and maximize. You'll see that there's a speed thing over here and a step run. I'm going to go ahead and run it. And this is Rabbit Hunt. So Rabbit Hunt is a fairly straightforward game. I'm going to stop it temporarily. So the Rabbit Hunt is a grid. Now this grid is not like Pac-Man. There is no going off the edge and going back around. Essentially, this is a walled area. The rabbit is this little brown dot over here. I know, very anatomically correct rabbit here. But I mean, we're just trying to use simple graphics. So the rabbit's goal is to survive for 100 turns. We're currently on turn 7. The fox's goal is to eat the rabbit because it's hungry. Okay, and these green blips are bushes. Bushes are areas that neither the fox nor the rabbit can enter, and they block line of sight, which is important over here. So let's run it and we'll see what happens. And boom, the rabbit has eaten the fox. The fox has eaten the rabbit after 100 turns. So we run it. Let's run this again a bit faster. And we just will notice how everybody's moving. The rabbit just seems to be moving every which way. The fox is kind of doing this pacing motion. He's moving back and forth. Let's see what happens. 42, 43, 47. Oh, he's found him and chomp. So we can look at the fox's code in a bit, but before we do, let's just talk about the general strategy for the fox. The general strategy for the fox is that as a predator, it wants to be pretty efficient. So what it's going to do is that is going to pace up and down as much as possible. Let me grab my pen so I can annotate the screen, right? So we saw the fox, and everybody can see the blue line being drawn. So we saw the fox move up, and then we saw the fox start to move down, and then we saw the fox move up again, all in that first column, right? So it was pacing, and then as soon as it saw the rabbit, it made a beeline in that direction, right? So the fox's strategy, if you look at his source code, and I will go over it, is fairly straightforward. I'm going to move back and forth. I'm going to bounce, basically. If I hit an obstacle, I'm going to either try to go around it, or if I can't, bounce off of it. And if I can't bounce off of it, then I'm going to choose a different random direction. But basically, he's pacing back and forth until he sees the rabbit. And once he sees the rabbit, he heads to that direction after the rabbit and tries to chase it down. The rabbit strategy currently is pick a random direction and move in it. It's not a very good strategy. So the object of the assignment is that you are going to play as the rabbit, and you are going to go ahead and alter the rabbit source code. In fact, that's the only file in this that you're allowed to alter. Specifically, this decide move function over here is what is basically each turn. This is called on the fox, and then called on the rabbit to move. So for a couple of things about this game, if you haven't noticed, this is a turn-based game rather than a real-time game. Turn-based games basically mean that people take turns playing, whereas a real-time game is something like, well, you've got real-time strategy like StarCraft, and then you've got first-person shooters like the infamous Call of Duty, or famous. It's pretty popular, right? So here, I'm going to stop for a second, and I'm going to hit the step button. So it's the fox's turn. What is those yellow lasers coming out of its eye? Out of it? Well, that's checking line of sight over there. Now it's the rabbit's turn, fox's turn, rabbit's turn, fox's turn. Notice that the rabbit didn't move that time. That's because it tried to move in a direction it couldn't, so it wasted a move. It sees the rabbit, and it's going to move towards the rabbit. Rabbit's going to move over here. It doesn't see the rabbit, but the fox will move in the direction it last saw the rabbit, because that's generally a good idea. So the rabbit's strategy here is choose a random direction, model.min, model.max. Model over here, it has a bunch of variables stored in it. Model, view, control, what is this? I'll go over that. But here we just choose a random direction. Fox is a bit more complicated, but let's see if we can't read it. Decide move. Can I see the rabbit now? That starts out as false. And then for int I is in min direction, and that's less than or equal to the max direction. You may notice that my font's doing something weird with that less than or equal to sign. It's an actual mathematical sign. That's just something that my font does. It's really cool, and I find it makes it very much easier to read. So so basically it's just, but it's not any different than what you would normally type. I++, if looking in direction I results in us seeing the model or the rabbit. So what is look? Look is a function that basically allows us to look around it, look in one of the 8 cardinal directions and say, hey, do I see this? What do I see there? And you're either going to see a fox, a rabbit, a wall, or a bush. Those are the 4 answers, right? The 4 different things that exist. And if I see the rabbit, I say, hey, I can see the rabbit now, and I have seen the rabbit. I set the direction to the rabbit, and I figure out what the distance is, which is another function. Distance says, hey, what's the distance between me and the thing in this direction? And then if I have seen the rabbit, if the distance to the rabbit is greater than 0, I subtract 1 and I return the direction to the rabbit. Otherwise, if I get to the point where the rabbit was and I don't see him, then I can't see the rabbit and I choose a random direction to go in. So basically, if I don't see the rabbit but I have, then I head towards the last known position of the rabbit. Otherwise, if I haven't seen the rabbit at all, then basically I continue moving in the same direction. And these things over here, these model.turns, very useful. You should probably look those up. They will really help. Current direction. So this helps it move around an obstacle. And if it's stuck, it just chooses a random direction. So this is what we call a model view controller paradigm for graphics, by the way. So it's very simple. Model represents the internals of the program. So basically the internal logic, the internal state, the arrays, the grid, where the fox is, where the rabbit is, what their positions are, and those kind of things, and whose turn it is. The numbers that correspond to each of the directions, right? The numbers that correspond to each of the objects on this. The controller are those buttons that you hit. Nothing too funky about that. And then the view is basically what's inside the window. So don't need to worry about this. Don't need to worry about this. The animal class, though, is very useful because, remember, a rabbit extends animal, which means a rabbit is an animal, meaning it can use all the functions that belong inside of animal. So here we see that basically the animal has the ability to choose a random direction. It has the ability to figure out the distance from something to another. It can figure out, given a direction, can I move in that direction? Okay. The model also has some useful things in it. The most useful one, though, is the turn function, right? You don't really need to know too much about these. You just got to figure out what functions do I need to call. And generally, those are the ones in animal. Figure out how Fox is working, like to get a good idea of this. All right. So turn is pretty useful because it makes your code very, it means that you don't have to really care about the specific direction. like you don't have to have code specifically if you see the fox to the north. You don't have to have code if you see the fox specifically to the south or anything like that. What turn does is that it says, given an initial direction, turn in a certain at a certain 45-degree angle. So for instance, if you give the direction north and 2, that will give you east, a 45-degree turn and a 45-degree turn. If you give it south and 2, so 6 and 2, 4 and 2, it will give you west. If you give it west and 2, if you give it west and 1, it will give you northwest because its direction's clockwise. The point of this is that it allows you to not really care what the specific direction is. So objectives for this program is to get your rabbit to survive as much as possible. And to give you an idea, once you understand this, about 10 to 20 lines of code can get you somewhere between an 80 to 90% survival rate. Above and beyond that, it's a bit tricky. But 80, 90, but basically it's very easy to get between an 80 and 90% survival rate. A good starting point for getting things done, let's see what time it is, today, would be getting the rabbit to look around, and if it sees the fox, move directly away from the fox, which is a losing strategy. It does not work very much because the fox will just chase you until you run into a wall. All right. Next, grader. The grader gives you your grade. What it does is that it runs 300 games very quickly. It says, hey, the rabbit choosing a random direction, and with the bushes being in random positions, the rabbit escaped 5 times out of 300, or 1% of the time. Your grade on this is out of 120 points. The first 100 points come from this program. And the way it works is what I call a square root curve, where basically we take the survival rate, take the square root of it, and multiply by 10. So if you get a 64% survival rate, a square root of that is 8 times 10. So a 64% survival rate is 80 points. A 81% survival rate is 90 points. So there's diminishing returns on this, but it enables you to basically see your progress go up very quickly. Next, your other 20 points are for successfully demoing. Now, this is a group project. You're allowed to work with other people on this. And there are 2 general strategies that I've seen employed for the rabbit. The first strategy is to essentially exploit the way line of sight works. Because these are cardinal directions, and let's go ahead and switch to a whiteboard for a second. So stop share, share whiteboard. Okay. So let's go ahead and see, here's our fox. Okay. Fox will look in this direction, He's going to look in the 8 cardinal directions. Maybe it's 4 cardinal directions in the diagonals. I don't actually remember. But he's only looking in straight lines. It's not like computer vision over here or you looking in real life. Like, so let's go ahead and let's see. Draw a different color over here. Right? This entire area over here that I'm drawing in orange, and this entire area, these are blind spots for it. Okay, and remember, this is turn-based. The fox moves, then you move. The fox moves, then you move. So let's say the fox moves. Okay, it looks around, doesn't see the rabbit. Okay, and then it moves. And then it moves into into line of sight with the rabbit. But it doesn't know the rabbit's there yet. Okay, the fox moved, it moved, and next turn it will be able to see the rabbit. But currently it's rabbit's turn. So it looks around and it sees the fox. So what it could do is that it can move out of the line of sight for its turn. So it could move parallel to the fox, or it can move away and at an angle to the fox and move into one of those blind spots. And the fox will never be the wiser. So that's one strategy, exploiting line of sight. Why won't this work at 100% rate? Because the fox might move, and you might end up in a position like this where it's really not easy to escape. You could end up in a position where the fox accidentally gets you because of a bush, or you might not be able to move away in an appropriate manner because of a bush. But compensating for that is how you get into like the 95 percentile rate for successes, 95 to 99%. Exploiting the line of sight though will get you into close to the 90% survival rate, the 80-90% survival rate range. The other way I've seen doing that is that the rabbit makes friends with a bush. So the fox goes after the rabbit, and essentially, if you're familiar with MMORPG terms, the rabbit's job is now to kite the fox. Kiting is a strategy in MMORPGs where one player gets a large amount of aggro on an enemy and basically makes it chase him around. So the idea here is that basically is that you let the fox see you deliberately, and then the fox then chases you around the bush. But if you've got a single bush, it's possible to move around the bush in a specific manner so you can get the fox stuck in an infinite loop, and then your 100 turns are up and you win. So those are the two general strategies. I find the kiting to be harder, but also very satisfying to do. Okay. So any questions on this one? Any questions before we get started today? I know I've spent a lot of today talking, but right now what I would like you to do is get this set up and running, even if you aren't able to code, and we'll be able to work on it more tomorrow as well as on Wednesday. So does anybody have any questions before I break you up into breakout rooms? Because what the rest of this session is going to be, I'm going to break you out in breakout rooms, and I'm going to go through each of the breakout rooms and check in on you individually or in quads. Probably in quads because there's 40 of you. That makes sense to everybody? So I'm going to invite you all into breakout rooms. And if you have any issues, just let me know. If you have an emergency, raise your hand and I'll get to you. Otherwise, feel free to ask your fellow students for help in the breakout rooms. You don't need to ask for permission to share a screen. You can just go ahead and share your screen. So breakout rooms, assign people into rooms automatically. For this first session, I'm just going to do automatically. If you have people you want to work with, let me know next time. Okay? It may be worthwhile to find out if you're in the same section though, so you can work together during your lab section. So there. Oh, rooms are all open, and I will go through the rooms in numerical order. People have been randomly assigned to rooms. All right, hello. All right, so let me go ahead and just say hi to everybody. And if you want to turn on your camera and say hi, awesome. So that way I can see who I'm talking to. If you don't, perfectly fine, no pressure. Hi, nice to meet you. I got an email from you, but I don't remember about what anymore.
I just had a question, the first question on the quiz.
Great. Did it have an issue? Did my first question have an issue on the quiz?
Do you want? I think so. Do you want me to say it or just let you read the email?
Go ahead.
So it was asking about the equals method, and like I looked it up. Like there's like the equals operator, and then there's the equals method, mm-hmm. And I saw that the equals operator, that's what checks the memory location, and the equals method, it like checks if the things in the memory location or like the actual things are the same. So
well, it does whatever the equals operator does whatever's defined by the equals method. So there's a default there's a default setting for the default setting for the dot equals method is to essentially do what double equals.
Oh,
That's
okay.
what it is. But there's no worries. There should be an unlimited number of attempts on the quizzes. That's why I'm
Yeah.
not. So the only punishment I give on quizzes is that you have to wait to take it again.
Mhm. Thank you.
Okay. All right. Nice to meet you. So is that Cecily or Cecily?
Yep, it's Cecily.
Cecily. Okay.
Hi.
Hi there. Nice to meet you. I'm glad to have you in the class. So have you? So any questions so far? On this assignment or no?
Nope, not yet.
Okay. Again, feel free to work with people. Again, I have and again to everybody, I have office hours tonight. So if you and if those hours don't work for you because you've got weird work commitments or whatnot, send me an email. I will find time. I have worked with students who have been in India, Japan, and Singapore, and I was in none of those locations. So I will find time to meet with you, even if it's a weird time zone issue. Hello, Jason.
Hello, how are you?
I'm doing good. So, any
how was
questions?
I don't really have any questions right now.
No
Just
need to.